So, yeah, I hope you have enjoyed the lunch somewhere. Yeah, and I found that there are lunch menus here saying Korean barbecue. But as being like a genuine Korean people person, it is a little bit off from the actual Korean food, but it was delicious. So I hope you have enjoyed it as well. So, yeah, now I'm going to talk about how Backend.AI, our AI infrastructure management solution, has integrated with the virtual cloud to unveil the power of the virtual cloud GPU performance. So, in the AI infrastructure is becoming a big challenges nowadays. So ChatGPTs and all the like AI tools from like many companies are coming out. Behind the scene, we have a very huge size and scale of AI infrastructures, and the challenges here is becoming more scale and dealing with the complexity and the cost itself. So I think there are two major pillars of the AI infrastructure challenges. The first one is performance. So the performance is implemented by the hardware itself, like AI accelerators, chips like NVIDIA, AMD, and others. And also we need to keep them like high performance, and to keep the maximum performance possible, we need to also consider like sustainable uh, energy providers and also cooling infrastructures and all the data center challenges all together. And the next pillar is the efficiency. So even we have a very like shiny, nice looking AI data centers filled with all the expensive hardware gears, if it does not run efficiently, we kind of are burning the money for no purpose. So for this part, we need to implement the software infrastructure to monitor and automate all the infrastructure challenges like auto scaling, automatic healing when there are some like faulty nodes, and uh, or the workload scheduling and management and the user control, quota control, security and role-based access control. All these like it's like a small but like a complex when they are composed together. So that's where we come with the Vultr and Backend.AI. So Vultr provides wide presence in the global scale with very cost-efficient bare metal performance instances all over the world with all the latest NVIDIA GPUs as well as many like lower grade GPUs as well. So with this advantages of a virtual cloud, we combined our backend.ai solution to leverage the power of virtual cloud. So our solution is here to provide the maximum utilization and efficiency of the same virtual cloud by like further partitioning and slicing and sharing the GPU instances in a more efficient way, but implemented in a full GUI compatible way, so that from researchers to developers, everyone can enjoy the uh, convenience. So the backend.ai is a platform built for like relentless scale. So basically, it makes it easier to manage your infrastructure and workload. And as being a container-based platform, it is based on many open source technologies as well as our own container orchestration engine called the Sokovan. And it scales from like a single JSON or Nano, like a very small scale embedded platform, to the thousands of data center GPU nodes as well. So the key concept is here is to squeeze the raw hardware performance to the last bit using the software technology. So basically, it runs and trains any AI model you want, and which is done in full GUI manner, and also automated workflow designer and with a fast track and also Bali to like one click provision your own AI models together. So, oops, yeah. Um, Yeah, Backend.AI is already proven across various industries and sectors, including all the public and private sectors. You may recognize some of the names here, like Samsung Electronics and LG Electronics and so on, and also like Fortitude, Hyundai Mobis, all the like big enterprise names in Korea, but who are also working in global scale as well. Um, so. Backend.AI can cover like up to thousands of GPU devices installed over like hundreds of GPU servers in a single cluster. And in total, we are already managing more than 10,000 GPUs in Korea. So we have already acquired the NVIDIA DGX ready software participation in APEC out of 18 worldwide since 2021, and we are making many technical and cloud partnerships to expand our presence in the global market. So Vultr is going to be our new cloud partner. So we hope that we could reach out with cost-efficient, high-performance AI instances that is combined with the convenience of the Backend.AI platform. So I'm going to go a little bit more about the Backend.AI platform's technical differentiation. So basically the AI tech stack based on Backend.AI and Vultr Cloud is composed of lower lower level infrastructure part and the higher level application part, including the inference engines and add-ons. So in the core, we use Vultr Cloud to provide the maximum bare metal performance of the NVIDIA GPUs with diverse global process. And we use Backend.AI for best performing container platform for AI and HPC. So here, I mean the best performing means that I think you may be familiar with Kubernetes and the many Kubernetes-based AI management solutions. So Kubernetes itself is a very well-designed software that implements reconciliation loop design to scale out your applications in microservice architecture with the standardized hardware configurations. But it comes in when it comes to the AI and HPC workloads that usually wants to exploit all the available capacity of individual computing servers and computing instances, it becomes very difficult to guarantee the performance and security isolation between the workloads from different tenants. So, for example, if you want to use like a very kind of expensive, like a B200 GPUs in clouds by sharing it to multiple users and multiple your customers, then it comes very challenging to guarantee the performance isolation when you just launch like a plain Docker containers or Kubernetes pods. So in Backend.AI, we have implemented our own sandboxing and the NUMA-aware scheduling and topology-aware device assignment, all the like very technical stuff that is automatically done for you. So we have tested our solution with the virtuals, the latest, very latest B200 NVIDIA GPUs. So I heard that this was like one of the first batch the virtual got from the NVIDIA. So we have tested several workload and ran benchmark to see how it becomes more efficient compared to our own H100 lab computers. So when setting the H100 performance as the baseline, like 1.0, it achieves more than like 6 or 5 times more efficiency in terms of the token generation performance of language models, and also it achieves much faster response time when it comes to time to first token, which is very important to make a user-friendly experience for the language model services because it makes the users feel like less lagging when the first response comes faster. So behind the scene, we are providing our own fractional GPU virtualization technology optimized for containers. So this is basically slicing the NVIDIA GPUs, streaming multiprocessors and the memory spaces, and make it like smaller to the view of the user workloads. So there are many similar technologies implementing this, like CUDA multiprocess servers or CUDA MIs, multi-instance GPUs, which are both based on NVIDIA's own like user level process technology or their own driver or hardware-based segregation. But it's our fractional GPU is different from their implementation. Which that overcomes several shortcomings of these technologies, such as like inability to isolate the error propagations and inflexibility when you want to reconfigure, resize the slice sizes on the fly. So we fully tested and verified the working of this technology on the NVIDIA's Blackwell platform with the assistance of Vultr Cloud. So yeah, I hope that you could enjoy this technology as a ready-made solution on the Vultr Cloud. So we have implemented many like detailed multi-stage schedulers for like a job assignment in the cluster level, head of like line blocking avoidances, or like a so-called backfilling algorithm in the like a more conventional Slurm schedulers. And you can also customize your own node assignment policies and so on. And in the node level, we implement hardware-aware, topology-aware scheduling and device assignment for individual containers so that you can integrate GPU direct storage and all the high-speed interconnects. So I want to mention that Virtual Cloud also offers InfiniBand interconnect options when you provision multiple instances. So that can be fully exploited and utilized with the Backend.AI platform. So yeah, this is a numeric aware part. And we also have a dedicated storage proxy component that abstracts vendor-specific file system accelerations. So this could be also employed to the virtual cloud to serve many different kind of storage backend. For example, I heard that you have the NetApp integration, for example. Yeah, you can utilize the full feature of the NetApp instances and such integrations on Backend.AI together. So you don't have to write your own code to use it better. Yeah, kind of. And we are also offering the MLOps authoring tool based on GUI, which is called the Fast Track, which provides all the like the pipeline designers and reserved executions and so on. And we also for the very high level end user centric interface called Pali. You know, Pali is the like Korean word that means quick, quick, fast, fast, and things like that. So we named it to, yeah, you can provision your own AI models in a very like a quick manner, just choosing some AI models from public registries like Hugging Face, and just one click to provision in Backend.AI and Virtual Cloud. And you can compare the language model performances and their behaviors by using like a side-by-side synchronized chat interfaces, and also you can automate like resource configuration, like how much GPU memory it requires to run on the like virtual instances and so on. And in NVIDIA GTC conference, we has also announced also announced that the native support for NVIDIA NIM containers, so you can run it on our platform by just registering your NVIDIA NIM API key. Then you can fully run the entire AI inference stack on top of virtual cloud and Backend.AI. So that's what I have prepared for today's presentation. So our mission is to make AI accessible to everyone in terms of for both developers and service providers, but also the end users. And now we are focusing on the making AI even more scalable. Scalable in like a two perspective, like more larger scales, and also like adaptive to like many different scales, from like very small embedded platforms or single workstation PC, and like a cluster of like a rack scale and a cluster wide, like a large scale and even global, like a geographically distributed manner. So this is our mission, and thank you for the coming this presentation. So yeah, I'm very excited to see what will happen with the virtual cloud and Backend.AI, the collaboration, and we could do add many values to the virtual's like high performance GPU instances, all scattered all over around the world. So yeah, thank you for coming, and yeah, I hope you enjoy the exhibition and the show. Yeah, thank you.